Hi, my name is Ainina binti Adam. For today, I would like to introduce our progress project. So, Anchorman steering geometry is a clever way to make sure a car turns smoothly without the tire slipping or wearing out too fast. Basically, when a car goes around a corner, the front wheels need to turn at slightly different angle. The inside wheel has to turn more sharply than the outside one. If both wheels turn the same amount, they end up fighting each other and sliding a bit, which isn't great for control on the tire. So to fix that, engineer came up with the Ackerman setup. It changed how the steering arms are positioned so that when you turn the wheel, each front tire point just the right way to follow its own perfect curve path. Like all the wheels are part of one big circle with the same center point. This makes the car easier to handle and way better at tight turns, especially in small or twisty space. That's all from me.
Next, I will explain more about the subsystem requirement that our group choose, that is Ackermann steering and row center height calculation. The Ackermann steering mechanism is a geometric arrangement used in a vehicle to ensure that the inner and outer wheel follow different turning radius during a corner, minimizing tire scrub and improving handling. The roll center is an imaginary point around which the vehicle chassis rolls during cornering. Its height significantly affects weight transfer, control, and grip.
And now I'll be talking about the basic calculations involved in our subsystem, which is the steering unit. So for our subsystem, the calculations will be for the Ackermann angle. So the first step is you have to assume some parameters as well as values for our calculations as shown in the terminology. So after obtaining all the terminologies and the parameters that are needed, you will have to find the inner wheel lock angle as well as the outer wheel lock angle. Other than that, the inner wheel turning radius as well as the outer wheel turning radius will also be identified. Then the average turning radius as well as the Ackermann value will be determined. For the last part of our calculation, we'll be identifying the Ackermann percentage.
Okay, this is our initial design from BYD cars. Okay, next this is our sketch design for BYD. So we have moved make a improvement to our recommend steering. So we focus on material and structural enhancement that we for lightweight and height and straight alloy. We replace traditional steel linkage with carbon fiber, reinforced composite or titanium to reduce unsprung mass while maintaining durability. Then we change with modular type design. We introduce adjustable line length tie rods. So for fine tuning, a common effect post assembly useful in motorsport and custom boot. So we focus on customer demand.
So I will explain about the HOQ. So the HOQ is a structured tool that helps us translate customer needs into technical requirements. It starts with identifying what the customer really wants and then link those needs to measurable engineering characteristics. As you can see at the left side of the table, we have listed five key customer needs. First, improve system performance. Second, ensure smooth system integration. Third, high reliability. Fourth, easy maintenance. And fifth, long-term durability. At the top of the row, we have the technical descriptor. These are the measurable factors that our engineer will focus on, such as component failure rates, integration times, output accuracy, operating hours before maintenance, wear resistant materials. And in the middle matrix, we show the relationship between each customer needs and each technical factor. A strong relationship is marked with a full dot, and a medium relationship is marked with a circle. So and the null symbol means there is no significant connection. We also use plus and minus symbols to indicate importance. So a plus symbols means that the technical descriptor is more important for a meeting. A minus symbol show it's less important. So that's from me. Thank you.
My name is Sajwa Ali bin Basri. My metric number CN230185. For conclusion, a command steering geometry is a fundamental design principle used in the steering mechanism of vehicle to ensure that all wheels follow appropriate turning path during a turn. The key benefit of this system is that it minimizes tire slippage and wear by aligning the steering angle of the front wheel such that their projected axes intersect common point on the rear axle. This allows the inner wheel to turn at sharper angle than the outer wheel, accommodating the different radius required for smooth cornering. In summary, recommend geometry improve vehicle handling and stability in turn. It reduces tire wear and energy loss due to slip. At high speed, however, slight modification or alternative system, such as modified command or parallel steering, may be preferred for better dynamic performance. Thank you. That's all uh, for my group.